and 6th grade, when I look at students there, by the way, I don't know everybody, I'm Marilyn Magnani, and I've been here forever, so I taught her, I taught half of you in the audience. And so when I look at 5th and 6th graders developmentally, and we know there's a range, there's a normal range, and so developmentally when they're thinking mathematically, they're coming out of that beginning, that multiplicative thinking. And that sounds like a ridiculous word, it sounds like some kind of disease, but it's what the idea is that before kids can get to think multiplicatively, think in groups, they're thinking additively. And this transition happens in 4th grade, but often I get 5th graders who haven't made that transition yet. That's a pretty normal place, 5th grade, for kids to start consolidating that idea. And it's huge. To be able to think multiplicatively allows kids to do that next huge step, which is proportional reasoning, which is the gateway to algebra. And without that thinking, and it's not something you can tell. You can't tell a person to think multiplicatively any more than you can tell an 11-month-old to walk. The 11-month-old has to be given the experiences and then they're walking, but you can't just say walk until they've had those experiences. And it's the same thing with thinking multiplicatively. So an assessment, like Kelly said, is that you're assessing all the time. And one of the things I'll ask the kids is we have a tricycle company and we're ordering wheels, and we have to figure out how many wheels we're going to order. And so how would we record that work? What would we, if we had we were making one tricycle, we need 3 wheels, 2, 6. Oh, and we look at a T-chart. You know, how do you organize your ideas? We need to do that so that we can see what's happening. We are looking for patterns. And we start building, and they'll say, oh yeah, we're counting by 3s, and all of these things that are kind of, as we've all said, seem very basic. And then you'll say, well, what about if I was building 46 tricycles? Do I have to have built the 45th one to be able to figure out how many wheels I need for the 46? Do I have to fill out this chart up to 45? Or is there another way I can get it? So a problem like that is given, and we look at it, and it's so clear because some kids will say, no matter what, well, I added 3, I added 3, I added 3, and it's constantly, and that's the way that they'll describe it. And somebody else will say, oh, well, I just multiply by 3. It's just 3 times that. And that shift happens sometimes in 4th grade, but by the middle of 5th grade, the majority of the kids are thinking multiplicatively. And they look for those patterns. They look for where those groups come. Because they have to hold an idea in their hand, the 2 things. They have to hold the unitizing idea that there's 3 groups, and inside that 3 group there may be 4 things or 5 things. And then each of those groups represent that. And that's a very complicated idea. And so when we talk about place value and kids really understanding that the tens place has groups of 10, and each of that group, those 4 groups of 10, has 10 things in it, is huge for kids. And until they can think multiplicatively, they really can't do much more than label place value. They really aren't thinking and using it in its deepest sense. So multiplicative thinking gets expanded, and of course it's multiplication and division. It's inverse, that inverse relationship, which comes up in my classroom all the time. This idea of undoing something and the power of that. And what happens? It happened in the 6th grade class the other day. Something came up and a discussion came up, and the kids, we were looking at a number. So I gave a problem, like it's a problem all of you have done. It was something like if we're going on a walk and I can walk at a rate of 5 miles an hour, how many miles will I walk in 6 hours? Or if I said I walked 23 miles in 4 hours, we'll make it easier, 24 hours in 4 hours, how many miles did I walk in 1 hour? So we were playing around with that, and then I reversed the question and said, well, how long did it take me so I walked 6 miles an hour or 4 miles an hour, whatever that problem was, and then I would reverse it and say, well, what if how long did it take me to walk 1 mile? So that's the inverse. And of course it's the inverse answer. So if it was walk 24 miles in 6 hours, that's 4 miles an hour. How long did it take me to walk 1 mile, then that's going to be the inverse of that. So the kids, they started playing around with that. Well, will that always work? So those ideas of what an inverse is, not an inverse is just flipping that fraction over, but what is an inverse? How does it appear? Where does it come? Why is it important? How does it work? Is really, really essential for them to get a sense of before they're working with it abstractly. And we know that we can create the illusions of learning with kids. And my favorite one, which you've probably, some of you have heard me say, is that one, ours is not to question why, just invert and multiply when we divide fractions. Why do we invert and multiply that fraction? And which fraction do we invert? You know, I've got many kids that come into me who have those, a lot of those, because I get kids sometimes for the first time in 5th grade or 6th grade coming to the school, and they memorize these things, they have no idea why they work, and so they're kind of lost at sea. It's like, I wouldn't even know what a division of fraction problem looked like. Where, as Alessandra said, we start with the problems. We start with, Jasmine's making pillows, each pillow takes 5/8 of a yard of fabric. She's got 12 yards of fabric, how many pillows can she make? Not taught them how to divide fractions. We're just immersing ourselves in problems that allow us to try to work. And most 5th and 6th graders can solve that problem without any problem whatsoever. They can figure out how to solve that problem. How many? Oh, I'm cutting these cakes, and I'm cutting the cakes into pieces that are 2/3 of the cake, and I've got 6 cakes. How many pieces that are 2/3 of a cake can I make from 6 cakes? And we start working that, and then we start doing the recording. So the context has to come first, because then it's meaning, and so that multiplicative thinking, that rational number idea, is at the heart of 5th and 6th grade. But it's not teaching the kids. They work from as getting the answer any way they can to more and more efficient strategies, and more, how do we code that? How do we look at that? How do we write that? That's all the trajectory that we have to get to, but it's got to be embedded in something that's concrete. So I've just got a couple little examples of kids working. So this was the geoboards that years ago I got a grant when the DuPont company was giving mini grants, and the kids were able to make geoboards, and we've got lots of them now because I didn't let them take them home. And so here are kids, and here's an example. They're doing geometry, but they're also doing fractions. The geoboards were made particularly with an array on them that has 36 square units, because 36 has lots of different good factors that you can use for fractions. And you can't buy these boards, and that's why I wanted to have the kids make them. And they're looking, and right now these two kids, these were 5th graders at the time, were looking at, first of all, they were constructing, you can see an isosceles triangle over here, and they were looking at the area. They were figuring out how many square units were on that, and what fraction of the board it took up, and how you write that. So there's all, and that's what they're recording here, and they're looking at base and height and area. And then as they did that, we charted these. They had all their individual papers there, and we charted these on the board, and we started looking at base, height, area, base, height, area, and in square units. We're looking at, there's all kinds of things that go on here. And we said, does anybody notice anything? If you know the base and the height, do you notice anything? And they're looking, and somebody goes, oh, it looks like if you multiply the base and times the height, and then you cut it in half, you get the area. And somebody else said, oh yeah, well I thought about it, if you took half of the base and then you multiplied it by the height, you get the area. Oh, and I said, well, are those the same thing? Well, no, they're not, or yes, they are. And of course, there's always at least one error that gets charted. And then somebody said, well, that works for everybody's, but so-and-so's, or that one, we don't have names on that one. And then they go back and they construct it on the board, and they say, oh, well, that was a mistake. It actually works for that one, too. And I said, well, do you think there's any triangle that it won't work for? Yes, they're sure that there's going to be a triangle that won't work. Okay, so take your geoboards home tonight and see if you can find a triangle it doesn't work for.
But bring them back.
But bring them back. And so there's that idea of they're involved in it. They've come up with it. They've derived the area on their own, the formula for the area of the triangle. And we do rectangles and parallelograms, rectangles, squares, trapezoids, triangles, and we look at the Pythagorean theorem. They derive the Pythagorean theorem. We do, today we're doing volume now in the 6th grade classroom, and we have a cylinder, and we were looking at, well, how would you find the volume in the cylinder, and the kids started playing around with that, and we'll get to that probably by next week. But the point is that we've got a reason to figure it out. There's a compelling reason to figure it out. And then there's they have to have a way of feeling that they're in control of having some tools to do that, and that they can do it. I have to empower them that they can do it. And then they come there, and lo and behold, they find, this is the formula for finding the area of any triangle. Base times height divided by 2. And we write it out a number of different ways, and we put it in our handbook, and then we have it. And even if they were to forget that, they know they can go back and figure it out, because that's exactly how they did it. So this is Brian and Hunter, I think, and then that was me talking to Chris, and he had found out, he started saying to me, and I was asking him, he said that he realized that if he divided any isosceles triangle in half, that was half of the rectangle. So he flipped over, he said this half over here was just over here. He said, so which is exactly right. And so I was talking to him about that. And he was very, very thrilled that he had found that out. And then we talked, and then he showed that to the rest of the kids. So, and then this is just one of my favorite for 5th and 6th grade. Has the school bus come yet? Obviously not. We're still here, aren't we? I was afraid I might have already gotten on it, rode to school, stayed there all day, rode back, got off, and was standing here forgetting to go home. Yesterday we started fractions. That'll do it. So my job is to feel like that kids are leaving me with this sense that fractions are very understandable, that they are just that extension of number that allows them to solve all kinds of problems that they couldn't before, that there's nothing frightening about them, nothing mysterious, that it isn't just a memorizing these procedures, but they really are able to interpret their world using now rational number, not just whole number. And that's sort of, so it's rational number, multiplicative thinking, and then